Welcome to XFO Intelligence. For decades, the idea of a truly general-purpose humanoid robot has been the stuff of science fiction, always just over the horizon.
Right.
But a new analysis from our team suggests that horizon is suddenly, much, much closer.
It is, but not for the reasons you might think. We've just completed a comprehensive analysis using our Deep Augmented Thinking method.
Okay.
And the findings are pretty counterintuitive. So while large language models, or LLMs, are the catalyst, the ultimate success of humanoid robots won't come from building a single smarter AI. No, it's about solving a much deeper, more fundamental problem.
Let's break that down. Our analysis started with first principles, right? Deconstructing all the hype.
Yeah.
And what you find is this fundamental mismatch. An LLM is a master of language and abstract concepts.
Right.
A robot is a servant of physics. The report calls this the grounding problem.
It's the perfect name for it, really. Think of it like this. You have this brilliant grand strategist, right, who can devise a 1,000-page plan for a battle.
Okay, yeah.
But they've never actually walked on a battlefield. They don't have an intuitive feel for terrain, for friction, or, how fragile things can be. The LLM is that strategist. It can tell a robot, hey, clear the table.
Yeah.
But it doesn't inherently understand the difference between a sturdy plate and a delicate wine glass.
So how do you bridge that gap between, language and reality? The report's critical insight is the need for a separate, crucial component.
Yeah?
A world model. And this isn't the LLM itself.
Okay.
It's a high-fidelity, real-time physics simulator, a kind of imagination engine for the robot.
Exactly. The LLM generates the plan, the what.
Right.
The world model simulates that plan to test the how. It asks, is this physically possible? Is it safe? It acts as an essential veto mechanism, a reality check that happens microseconds before the robot acts.
Wow.
This is the core technical solution.
And solving it unlocks this whole opportunity landscape, which the analysis structured into a 3-layer stack.
Yep.
The first is obvious, the tech itself. Companies innovating on world model software, specialized hardware, batteries.
And the second layer is applications. The report forecasts deployment in waves. So wave 1 will be in highly structured environments we already control, manufacturing, logistics.
Okay.
Wave 2 moves to semi-structured spaces like hospitals, retail, and then wave 3 is the final frontier, complex, unstructured environments, like our homes or construction sites.
But that third layer, the ecosystem layer, that's what I find most compelling.
Yeah, that one's huge.
The analysis suggests that the largest economic opportunities might not even be in selling robots, but in providing the services that make them work. Think robot operations as a service, ROAS, where you just pay for a task to be done, not the machine. Or totally new jobs in safety auditing and managing fleets of robots.
But this massive opportunity brings equally massive systemic risks.
Right.
You have labor displacement, the ethical nightmare of accountability when a robot makes a mistake.
Right.
And the very real safety challenge of value alignment becoming a physical engineering problem. And this led to the most creative part of our analysis. To forecast how such a complex system would behave, the team turned to biology.
They modeled the system using a slime mold algorithm.
Yeah.
It sounds strange, but it's actually a really elegant analogy.
A slime mold is a decentralized organism. It has no brain,
Right.
but it finds the most efficient paths to food by leaving behind a chemical trail of pheromones.
And the simulation showed that a fleet of robots could operate on the same principle. Instead of chemical trails,
Yeah.
they leave behind digital pheromones in a shared network. So when a robot finds a safe, efficient way to do a task, like that specific grip for the wine glass, that path gets reinforced. The entire network learns it instantly.
And conversely, if a robot encounters a hazard or makes a mistake, that action is marked with a negative pheromone, a warning that propagates to every other unit. This is how you get emergent safety. It's not programmed into one robot.
No.
It's a learned property of the collective. The report calls it the slime mold safety emergence framework.
It's a total paradigm shift. Don't build one perfect isolated robot. Instead, you build a decentralized collective intelligence that learns and self-organizes. And this leads directly to the strategic recommendations. For developers, stop focusing only on the LLM.
Exactly.
Invest heavily in the world model and these decentralized learning protocols.
And for policymakers, don't write rigid rules for a technology that's evolving this fast.
Right.
Focus on performance-based standards. Certify that a system has a robust world model and a reliable collective learning mechanism. And crucially, invest now in just transition programs to reskill the workforce for all the new ecosystem jobs.
The conclusion is, it's just so clear. The age of the general purpose robot is upon us.
Wow.
But its success and its safety hinge on our ability to solve this integration problem by embracing these decentralized, bio-inspired systems. It's about fostering an intelligent, adaptive collective, not just one intelligent machine.
It truly shifts the frame from a single mastermind AI to a resilient emergent system.
It does.
Which leaves us with a critical question to shape that emergent intelligence. Now, here's a question we'd like you to think about. As these robotic fleets learn from our world to operate within it, what is the single most important value or rule we should hardcode into their collective memory from day one?